Okay, okay. If you're here, you want to do or look at or review the 1998 AP Calculus AB examination. Man, 1998. This is the year 2022. This exam is 24 years old. Do you know what that means? If this exam is 24 years old? If you have parents, if you're 18, well, obviously you have parents. How else did you get here? But if you're 18 years old and you have parents that are 42 and they took calculus, they might have sat for this exam. How crazy is that? The depths to which, how far we can go to practice for the AP exam coming up. Whew! I'm going to do problems 1 through 10. Again, no calculator for this section, okay? This is section 1, part A, no calculator. All right, let's do this, and let's get going. Number 1 states, what is the x-coordinate of the point of inflection of the graph y equals 1/3 x cubed plus 5x squared plus 24? All right, point of inflection. I need the second derivative, so I need y double prime. All right, simple. So the derivative would be x squared plus 5x, all right? And the second derivative would be 2x plus 5. All right, all right, all right. Wait, I lied. This is 10x here, which means this would be 10. My brain went ahead and I was trying to figure out what the answer was first. Woo, good thing I caught that. Okay, point of inflection. The second derivative is equal to 0. All right, so I'm going to set this equal to 0. All right, and all I'm going to do is solve for x. Okay, subtract 10 from both sides. So I've got 2x equals -10, and then divide by 2. And my x is -5. That's why I had 5 on the brain, if you believe me. Maybe that's true. Maybe it's not, kids. But I caught my mistake, and I got the right answer. Choice D, -5. Number 2. I love when they give us graphs. The graph of a piecewise linear function f for x from -1 to 4 inclusive, meaning I include -1 and -4, and +4, is shown above. What is the value of the integral from 4 to -1 of f of x? Integrals, those are area under the curve, okay? We can do things that way, just figuring out the area under the curve. What's great here is these are just geometric shapes, okay? First, let's establish something. I want from -1 to 4, okay? So I'm going from here to here, those 2 dashed lines, all the areas underneath the curve, all right? Here's the x-axis, and there's a reason why I'm pointing this out right here, okay? I will tell you in one moment. Now, a lot of people see that trapezoid and use the trapezoid area, which you can, but when Mr. Visca sees it, I like to break it up into triangles and rectangles, make it super simple. This is a width of 1 and a height of 2, so that area is 2. 1 times 2. This is a length or base of 1 and a height of 2. It's 1/2 base times height for the triangle. So half of 2 is 1. Okay? The triangle on the left is the same thing. 1. Okay? So we got 2, 1, and 1. On the top here we have 4. If I add up 1 plus 2 plus 1, it gives me my 4. Okay? But we have these areas below here. And again, I'm going to do that one in red. It's a 1 by 1 cube, so this is 1. Okay? This is 1 by 1, but it's a triangle again. So it's 1/2 base, which is 1, times height, which is also 1. So it's 1/2, 1 times 1, which is, oh my God, a half. So in the bottom, if I combine those, I have 1.5 or 1.5. Now, the important thing to know about integrals is the following. Anything above the x-axis should be considered positive. Anything below the x-axis should be considered negative. It's like displacement versus total distance. If they wanted you to count this 1.5 as positive, they would have put absolute value bars here somewhere, okay? But they didn't. So anything below the x-axis should be negative. So I have a positive 4 for the top here. I have a negative 1.5 for the bottom here. When I combine them, that's 2.5, the area under the curve. That is choice B. 3. Oh, beautiful. No word problem, no graph. It's just integrate 1 over x squared dx. What I always tell my students to do, if I can, because it's always easier working with just exponents, I'm going to bring this x squared up, which means I need to negate the exponent. So I end up with this. Okay? Now my rule is, it's reverse power rule. I add 1 to my exponent first, then I divide by that result. So I end up with, okay, negative x to the negative 1, or negative 1 over x, because now I'll bring this back down. How come I want to bring this back down? Because I have bounds, okay, and it's going to be easier from 2 to 1. It's going to be easier to do this without negative exponents. So I have negative 1 over 2, that's the first one, the upper bound, minus negative 1 over 1, okay, negative 1/2. This ends up being negative 1, but I'm subtracting a negative 1, which makes it positive 1. Negative 1/2 plus 1, positive 1/2, and that is choice C. All right, good. We're moving good. Number 4, if f is continuous from a to b for all values of x between a and b, and differentiable for those same values, except it doesn't include a and b, okay? Which of the following could be false? Okay, could be false. This can never be false, okay? That's that, what, intermediate value theorem? That's a rule, okay? Between a and b, there's some point c that exists, that the average change between my endpoints has to equal the instantaneous change, or the derivative at one point in between. That's a rule. That has to be true. Okay? F has a minimum from A to B. Yeah, it does. Okay, it's differentiable. Okay, it's differentiable everywhere, which means it's continuous. There's a minimum. It has to have a minimum, and it has to have a maximum. Okay, it is continuous and differentiable. There are no breaks, whatever. Okay, if there are no breaks, okay, if there are no breaks and it's continuous, that means you can take the integration of it as well. That has to exist. The only one that could be false. All of those have to be true. There's not a chance that A, C, D, or E is false. Let me say that again. There is no way that A, C, D, or E can be false. There's not even a chance. There is a chance for this to be false. Now, here's the problem. Someone might say, well, the derivative of 0 is a horizontal line. Between A and B, I can have a horizontal line, like right here, right? Let's say this is A and this is B. Okay, I could have this. You could have that. But you can also, it could be false. There's a chance it could be, I could just go straight up like this, straight up. There's no point where there's a horizontal line between this A and this B, is there? Okay, that could be false. And that's why your answer is choice B. Number 5, oh, another brilliant one, no word problem or anything. Integrate from 0 to x the sine of t dt. Oh boy, please, please resist the urge. Please resist the urge to do this. Oh, well, the x just goes in and that's just sine of x. Because my bound variable is different than the integration variable, and I know I'm supposed to just put that in. Okay, so many people circle this one. That is not true. That is only true if I was taking the derivative of this, because these go bye-bye, the integration, the dummy variable, then the x goes in, okay? We are not taking the derivative of that, which means I need to integrate that. And yes, my upper bound is going to be x. So what do I take the derivative of that would give me sine? Again, I have the derivative. If I integrate this, that goes backward to get the original equation, right? I've done this on previous videos, okay? There's the equation, the first derivative, the second derivative, okay? Moving from left to right is the derivative, okay? But when I move back, that's the integration, okay? So this is what I have here. I'm integrating, I'm going backward. What would I have here that would give me the derivative? Okay, I'm trying to go back. Negative cosine of x. That would give me, if I take the derivative of that, that would give me sine. Okay, I want that from x to 0. So I'm going to plug in my x first. Negative cosine of, well, just x. Minus negative cosine of 0. This is where it helps that you remember your values for trigonometry. The cosine of 0 is 1, this right here. If you forgot, cosine is the cup, starts up high. Okay, comes down to negative 1 all the way up to positive 1. Here's my 0. When your x value is 0, here your x value is 360 or 2 pi, 180, so forth. When your x is 0, your y is 1. All right? So this is 1. I still have to negate it, and I'm subtracting it. When I subtract a negative, well, it's like plus 1. You can't do anything with this. You don't have a value for this variable. So your answer should look like this. Okay? I don't see that up top. This is addition. Okay? I'm adding two things. In addition, order does not matter. What do I mean? 2 plus 3, that's the same thing as 3 plus 2. I can switch them. So let's put the positive one first, and let's put the negative cosine next. Choice E. Choice E. And I'm telling you, you're going to have to know sine, cosine of 0, 90, 180, 270, 360. Or in terms of pi, in terms of radians, pi over 2, pi, 3 pi over 2, 2 pi, okay? And you're going to have to know those special angles too, like 30, 45, and 60. So if you don't know those, brush up on those. Number 6. Well, we're moving along really well. Number 6. If x squared plus xy is 10, then when x is 2, what's dy dx? I'm going to take the derivative of this. I'm going to do this implicitly. Okay? I'm going to take the derivatives of every x and every y, except when I take the derivative of y, I've got to put dy dx right next to it. Okay? Or in my case, I'm going to use y prime. All right? Dy dx is the same thing as y prime. It's the derivative of y. So I have x squared. Derivative of x squared? Well, that's 2x. Plus, I need to use the product rule here. It is the first one times the derivative of the second. Okay? And we will do the y primes in purple. You know what? Let's go with the color that sticks out even more. Let's go green. Okay, so first times to the second, plus the second times the derivative of the first. Okay, the derivative of x is just 1. Equals, the derivative of 10 is 0. I'm not supposed to leave that 10. I take the derivative of everything, even the constant on the right-hand side. All right, so let's get y prime alone. I made it green on purpose so it sticks out. Okay, so I've got, all right, well, this is going to end up just being plus y. Let's just simplify that right there. We want to keep anything with a y prime alone on one side. Everything else has got to move over. Got to get over. So let's subtract 2x and subtract y. Subtract 2x and subtract y. X, y, ooh, no, we want to keep that green. X, y prime equals negative 2x minus y. The last thing we do is we just divide by x. That's an x. So this is the derivative. That's my dy dx. I wrote it as y prime. Okay? But here's the kick. They don't want the expression. They want the actual value. I know what x is. I want this at x equal 2. Okay, so let's do that right here. So y prime, or dy dx, is the same thing as y prime, equals. Okay, I'm going to put a 2 in for x's. Okay, that's negative 2x, x is just 2, minus, I don't know what y is yet, all over x, which is also, still 2. If I have a coordinate that I'm looking for, so I have x is 2, I don't know what my y is. I always go back to the original equation. Always go back to the original equation. I'm going to plug in a 2 for x and solve for y there. So let's go, okay, I'm going to put a 2 in for this x and for this x. So I've got 2 squared plus 2 times y equals 10. All right, oh, that's not too bad. That means 4 plus 2y equals 10. Right now I can tell y is 3. Isn't 4 plus 6 3? That should be 6. And 2 times 3 is 6. So I know y should equal 3. But for some of you guys that for some reason have a difficulty understanding that, we can just finish solving this. Let's subtract 4. Subtract 4. We say 2y equals 6, divide by 2, and y is 3. So if y is 3, y is 3. Negative 4 is what I get here. Minus 3 all over 2. Negative 7 over 2. That was a decent amount of work for a multiple choice question. Negative 7, 2. Choice A. Number 7. Ooh, man, we're getting a lot of problems where it's just an equation to solve. I like it. It's my wheelhouse. Woo! That's a wheelhouse, kids. Anyways, that was a phrase from 1998. I'm kidding. Number 7, integrate from 1 to e. That is a number e, okay? The expression x squared minus 1 over x dx. What we can do here is before I do any integration, I'm going to simplify this. And it is going to be really helpful to you if you can identify when you can simplify fractions and when you can't. Okay? In that parenthesis, I'm going to break that up as saying x squared over x minus 1 over x. Okay? Because if I combine those, and I do that, I end up with x squared minus 1 over x. So all I'm doing is I'm taking what I started with and breaking it back up. All right? And the good thing with this is my first term can simplify, and x can cancel out 1. I get x minus 1 over x. That is going to be a lot easier to integrate, okay, from 1 to e, and of course dx. So I've done no integration yet. I've only simplified, okay? I've only simplified what I want to integrate, and now it's going to be cake, okay? So when I integrate this, I get x squared over 2, because I add 1 to the exponent, then divide by that new exponent, minus, remember, I want to find out, and this is a rule, what would I take the derivative of that would give me 1 over x? The derivative of ln of x would give you 1 over x. That is a rule. That is a common thing on the exam. Okay, dealing with e and ln of x. Okay? Derivatives, integrations of both of these happen frequently. Okay, so that was an integration for ln of x. Well, to get ln of x. I want this from e to 1. Okay, so let's start. Let's put an e in there first. E goes in for my x squared over 2 minus the ln of e. Okay, now I put a 1 in there. 1 squared over 2 minus the ln of 1. All right? Okay, in case you didn't know, again, rules come into play. The ln of e, well, that's just 1. The ln of 1, that's 0. All right, so let's simplify what we got. I have e squared over 2 minus 1. Okay, this is going to be 1 squared is still 1, so it's 1/2. But I'm subtracting 1/2. So I'm looking at my answers here, and I'm going to have to combine these two values. And it looks like it's going to be, let's turn this into fractions or combine them. 1 is the same thing as 2 over 2, okay? If I have negative 2 over 2 minus 1 over 2, that gives me negative 3 over 2. This is still in the beginning. E squared over 2. All right? I could combine those because the denominators are the same. But look, it's already here. Choice E. If this was short answer, or maybe multiple choice that presented it differently, they might combine those because the denominators are the same. I could combine them. Okay? But our answer is right here. That is choice E. Very good, very good. Number 8. Let f and g be differentiable functions with the following properties. Okay, 1, g of x is greater than 0 for all of x. And 2, f of 0 equals 1. If h of x equals f of x times g of x, and if h prime of x is f of x times g prime of x, then f of x equals. This problem really is just, I like these problems, but I kind of don't. This problem is just testing you to see if you can kind of decipher a code or a pattern between h of x and h prime of x. Because if you can compare those things and make one realization, you answer this question. All right? H of x is f of x times g of x. Okay? Now, h prime of x. The first thing I thought of when I did this was I'm going to have to do the product rule. This times this. Okay? The first times the derivative of the second plus the second times the derivative of the first. I mean, and I could, but there's really a simpler way. They give you the derivative already. Okay? Whatever g is, I have the derivative of g. That makes sense. But notice that f of x stays the same. Okay? That's what you need to catch. What is the only situation, well, I should say one of the most common situations, where if you have an equation, you take the derivative of it, and what's in front stays the same? If it's a constant, that's not 0. Okay? What's 3x? The derivative of 3x is 3 times whatever the derivative of x is, right? Which in this case is 1. Okay, this stays the same. Okay, 3x squared. You might say to yourself, well, the derivative of that is 6x. It doesn't stay the same. my friends, look at the notation here. Look at the notation here. It does. The 3 stays the same. Then I take the derivative, okay, if g is x squared, I take the derivative of x squared, which happens to be 2x. Then I multiply them together. Okay? So when you see it like that, you're like, oh, that makes so much sense. But we're not really trained to see it like that a lot. Okay? So that's why this question, E is the only non-zero constant listed. Okay? Anything with a variable is not a constant. And this is 0. I mean, if I put 0 in for f of x, I mean, it'd all be bye-bye. Okay? Everything would go away if I multiply anything times 0. So when you look at it through that lens, well, that's a hard thing to kind of figure out. I mean, I had to look at this for a moment or two. I mean, longer than a moment or two. I'm not going to be proud or have my pride lose this teachable moment of sometimes you really got to look at a problem until the light bulb goes off. This is one of those problems. Or in this case, I should say, the light bulb goes on. Boom, you get it. 2 more problems, 9 and 10. Let's start with 9. Okay, the flow of oil in barrels per hour. Okay, so this is a rate. Barrels per hour, that's a rate. Okay, through a pipeline on July 9th is given by the graph shown above. Of the following, which best approximates the total number of the following, which best approximates the total number of barrels of oil that pass through the pipeline? If I have a rate, in this case it's barrels per hour, and I want to go back, I just put rater. If I have a rate, not a rater, and I want just barrels, like the quantity, that's integration. Okay? I have the rate, I want the quantity. Okay? That's integration. Integration, and we said this earlier and I'm going to go back here for problem 2, that's the same thing as area under the curve. Area under the curve. Now, approximates. These aren't triangles or trapezoids or rectangles, but I can approximate what this is. Area. Okay? First of all, I don't know, this kind of looks like from here to here. Let's figure out what this is. Okay? It's up 100 and over 24. So this area of this rectangle, 24 times 100, is 2400. That's the area here. Now, I told you guys before that Mr. Visca likes using triangles, okay, because we're just approximating this. These triangles are pretty much the same. They are 6 wide, because look at our 6 wide, and they go up from 100 to 200, so they're up 100. Okay, so 1/2 of 6 times 100, well, that's 600. Half of 600 is 300. That's this triangle, and this one's the same thing. So let's add them all together. 2400 plus 300 plus 300. Oh, look at that, 3,000. Choice D, 3,000. Choice D, 3,000. Good old-fashioned instantaneous rate of change. If it's an average rate of change, I would need change in y over change in x, or change in y over change in t, because we use time in calculus. We would need coordinates f of b minus f of a all over b minus a, which our younger selves and less complicated selves really like to say y2 minus y1 over x2 minus x1. That is for average. That's when life is easy. But it doesn't say average, does it, kiddos? It says instantaneous. But because we know our rules for derivatives, I'm just going to take the derivative of my function, okay, at x equals 2. Okay, I'm going to take the derivative of this and plug a 2 in for x. Just a good old-fashioned take the derivative question. Good. Okay, low times d high. low d high minus high d low. I draw a line and I square below. I love that. In case you didn't know, low is x minus 1 and high is x squared minus 2. It's a rhyme. Low d high minus high d low, draw a line, and square below. They rhyme, low and square below. If I do this wrong, because in subtraction order matters, if I do it wrong and I put high d low minus low d high, draw a line and square below, it doesn't rhyme. So it's just a little, it's like, you know, it's what made Dr. Seuss famous, right? Okay, so low, just as it is x minus 1. D high, the derivative of the numerator, is just 2x. Minus high, just as it is x squared minus 2 times the derivative of below. The derivative of x minus 1 is 1. And then I square everything that's below. So what's in red is my derivative. Now, I'm not going to simplify that with all those x's. I know that's at x equals 2. I'm just going to plug a 2 in for every x. It is so much easier to make a mistake when you're simplifying. Okay? I'm going to throw a 2 in for every x. You ready? 2 minus 1, because this was one of my x's. Times 2 times 2, because this was an x. Minus 2 squared, because this was x squared, minus 2, times 1, this was a constant, all over 2, because it was an x, minus 1 squared. All right, well, let's just do the math. All we did is plugged in our 2 for our x's. Da 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 da. There were 4. There we go. And here we go. Ready? 2 minus 1 is 1. 2 times 2 is 4. 1 times 4 is 4. 2 squared is 4 minus 2. That's 2 times 1. That's 2. All over. 2 minus 1 is 1. 1 squared is 1. 4 minus 2 is 2 over 1. 2. And there's a lot of 2's. I got to check my answer. Is that 2? It's 2. There were so many 2's. So let's circle the answer, 2's. All right. It's good. 10 problems. Let's 10 problems, 32 minutes. All right, I'm getting better. Give me a like, give me a follow, like me so I can get you know, more notoriety out there and more people who need help with math will have availability to me. Okay, follow me so you know every time I post a new video, you'll see it. All right, I'll see you later. Bye-bye.